Okay, so I think we should make a start, and I'm sure people will start entering as things start. Welcome to the seminar, everybody, and thank you for joining us. It is my pleasure to introduce today's speaker, Olga Popova. Olga is a senior researcher at the Leibniz Institute in Regensburg. And today she'll present her work on how extreme temperatures affect economic activity and income distribution in Russia. Thank you very much, Olga, for agreeing to present today. So just the usual reminder that please mute your microphone while Olga is presenting, but feel free to unmute if you have any question during the seminar. And also just a reminder that the seminar is being recorded. Okay, over to you, Olga.
Thanks a lot, Matov. Also, thank you for the invitation and nice introduction. I will talk about our paper with Vladimir Otrachshenko from Center for International Development and Environmental Research in Justus Liebig University Giessen. And we are exploring in this paper how weather, single hot and cold days and consecutive cold and hot days, as well as precipitation, affect various income distribution indicators in Russia. And please, if you have any questions, please feel free to stop me during the talk, and I will be happy to answer. So the outline is general. I will introduce you what interested us in, led us to having this topic, and then talk about why exactly we think that there could be an effect of weather and temperature on inequality indicators, and then present you our methodology and the results. So one of the motivating starting points for us in doing this project was the Guardian articles in 2018 that basically told that heat is becoming a new threat for everybody and a new threat globally for increasing inequality. And that now globally in various places in the world, the countries experience more and more hot days, but also the cold waves. So basically the countries could now be divided into those who have increasing number of hot days and those who have hot days and not have hot days. And basically the literature also looks into this phenomenon in various countries. And one of the recent papers, for example, looks into global data on the country level. And one of the arguments there is basically the economic growth of your country depends on where you are as opposed to equator. So the closer you are to the equator, the more likely you will have lower GDP growth rates. And this is basically sort of predetermined pattern that if you are the poor country located closer to the equator, it is more likely that you will become even more poor because the number of hot days will be increasing over time. From this picture, actually, it looks like the country level, Russia would be the country that would benefit most from this situation. If you look into this picture, sort of greenish, bluish countries are the countries that over these years experienced GDP growth and sort of benefited from the rising number of hot days. This is the country level evidence, and however, if you look into this into let's say from subnational point, this is the simple correlation figure where we plotted the average number of hot days during the last 20 years and the average GDP. Here, even from the simple correlation, you could see that the pattern here is negative. So increasing number of hot days leads actually to decreases in GDP per capita in Russia. So basically, the country level evidence would not always give the true picture of situation how the weather and temperature would affect GDP and other indicators in Russia. So we decided to look into this into more details, and we use subnational level data regional panel for the last 20 years to explore different effects of temperature and precipitation on the distributional indicators, income inequality indicators, GDP. And while doing so, we focus not only on the single hot days, meaning that we have a day with extremely hot or extremely cold temperature, and this is just one day we are able to measure that impact. Apart of that, we're also looking into the consecutive days, which would be the heat waves of several days with the specific hot temperature that occur consecutively, and we are measuring these impacts for the hot days and for the cold days. I will talk about the structure of the data and specific measurements a bit later. Apart from that, we are also trying to provide the evidence and explain what would explain this relationship between inequality indicators and temperature. And we are able to identify several labor market channels that could be explaining this effect. And finally, we also look into some heterogeneity, because the Russian setup actually gives us a lot of opportunities to study also the regions from different perspectives. For example, we are dividing countries that are relatively poor, regions that are relatively poorer or relatively richer. So if we have mean GDP over country, regions that would be having GDP per capita higher, that mean that we would call them rich, and lower we would call them poor. And similar way, we are also dividing regions into hot and cold. So if a region has a number of hot days relatively higher than the average over country, then we attribute this region as a hot region. And if it is a region with a relatively lower number of hot days, then we say this is a cold region. I will again talk about this a bit later. So generally, if we look into the literature on that, the seminal papers, even though they are quite recent, still they mostly looked into the effects of hot and cold temperatures on mortality. And for now, the literature on that is still increasing, and using the subnational panel data, the researchers examine how these effects would be in India, in Mexico, in US, in China. And the general finding here is that both the hot and cold temperatures increase mortality. We also contributed in that direction. One of our first papers on that, published in Ecological Economics, focused on the effects of hot and cold weather on mortality. Then we extended this framework looking into the also heat waves and cold spells. And the most recent paper also looks into the violent mortality in Russia. This is basically the literature that sort of served for us also as a baseline literature to look into the other socioeconomic indicators, and specifically look for the GDP and inequality indicators. For that, literature is also fastly developing now. A number of papers now look into the country level estimates. So how the extremely hot temperatures would affect economic growth in different countries in a cross-country setup. And I have shown you the picture for one of such articles. However, the subnational sort of within country evidence on the effects of extreme temperatures is still quite rare. There are a couple of papers that look into this setting using US data. And there is, to our knowledge, also one paper that looks into regional cross-country framework, and also looks how temperatures would affect economic growth. We also contribute into this direction and use the regional panel data from the Russia and look not only on the GDP per capita indicators, but also into various measures of income inequality. So to provide the more complete picture how the weather and hot and cold temperatures would affect the income inequality and distributional impact. And generally, if we talk about the channels and the mechanisms, here the starting point is actually the epidemiological literature that say that we have some, as a humans, we have certain limits that are temperature limits that are comfortable for us. In winter, this is estimated to be 20-23 degrees, in summer, and 22-25 degrees Celsius. What it means that if the temperature in the air is within this limit, this is a comfortable limit for human body. And if the temperature is outside these limits to any side, this would be the uncomfortable temperature that would induce a lot of different adjustments of the human body. And the literature on that is also increasing. What are the effects that identified, for example, is that extremely hot temperatures, and this is a thermal stress for the human body. They reduce cognitive performance, they reduce work productivity, induce relocations from different industries from
Olga, so sorry to interrupt. Isn't this a bit confusing to have why is it different between winter and summer? Shouldn't the body at all times like the same temperature? Or what?
This is also maybe related partly to sort of usual temperatures, because winters are relatively cooler, and so the human body also adjusts over time to having a relatively cooler temperatures during the winter. So I think there is no much contradiction in that, and basically, if you look into these numbers, these are still quite close to each other. So
we humans adjust to reality a little bit, something like that. This is the intuition here. Okay, this is biology here or something, but okay. Sorry, sorry to interrupt. Okay.
No, it's okay. It's important to clarify. So yes, there are different effects that are playing a role here, and specifically related to the ones that are important for the labor market, and that could be also the channels for explaining why weather would then affect inequality on GDP indicators. So specifically, if we talk about this literature in a bit more details, we could think of different mechanisms that would help to explain why weather, extremely hot temperatures primarily, but also extremely cold temperatures to some extent would affect regional GDP or income inequality indicators. So first, since we have a lower productivity during the thermal stress, that would may mean that individuals would increase their transitions from employment to unemployment, and also from employment to non-work. And there is a literature on that saying that yes, during the extremely hot temperatures primarily, there are more relocations like that. Then again, due to lower productivities and also due to reduced number of working hours, this could also be related to wage reductions. And this is specifically the channels that could be relevant for increases or changes in the income inequality. And here it could be also that some industries would be affected relatively more, like agriculture or construction, and other sectors would be affected relatively less.
Olga, I don't know if you see this or not, but John has raised his hand. He has a question.
I actually don't see the raised hand, okay. So it would be best if if there is a question that is asked like directly.
Okay, I just wanted to be polite. I was just thinking that I live in a country that has that's known for its high temperatures, Australia, but it has very different geographical regions with respect to humidity. So I live in an area where every single summer we get temperatures of 45 degrees and more, but it's a very dry heat. And if you go a little bit further north towards the equator, it's a very wet, sticky, muggy kind of heat. And so that's much more uncomfortable even at 30 degrees because it's just so hot and sticky. And so I was just thinking, like you're focusing very specifically on temperature, yet the temperature, humidity interaction is really important in terms of all these sort of health issues that you talk about, sort of people overheating or suffering some sort of a health collapse. And so I was just wondering to what extent you'll be talking about that.
Yeah. Thanks a lot for the comment. Indeed, the interaction of specific temperature climatic variables would be important, weather variables. In our setup, I will come to that later. We will be controlling for temperature and precipitation. And so, and also in the literature, it is found that the specific also combinations of temperature and precipitations could be affecting different the health impacts, having different health impacts. Humidity, yes, it is also important. In our setup, we would not be able to specifically control for the humidity, but partly we do so by controlling for the amount of precipitation. And I will also stop and talk about the climatic conditions of Russia, and you will see that, yes, this is a bit different setup, of course, as compared to Australia. But what is interesting is that we are able to look into the impacts of extreme cold and extreme hot. By extreme cold, I mean it will be minus 23 and lower, and the extreme hot for our setup it will be 25 plus. But I agree that in different countries this temperature may be not classified as extremely hot temperature, and different variations with the humidity and precipitation could be producing different impacts. But what is important for us is that it would be the temperature that is indeed considered as a hot temperature. And so to shortly answer to your question, we control for precipitation but not for humidity. But we are also indirectly accounting for differences between these different regimes. So yes, on the mechanisms, there could be changes in wages, and also could be changes in the employment. So the people could, if there is a possibility, relocate from sectors with greater exposure to sectors with lower exposure. And this could also be done if using the migration channel. So you would migrate from regions with relatively higher exposure to regions with relatively lower exposure. All this in combination, it is of course quite difficult to disentangle any particular channel, but all this in combination could also change the overall picture regarding the composition and structure of industrial and agricultural development in the regions. And what is so far found on the country level in cross-country setup is that richer and colder countries would receive in this setup relatively more benefits from global warming than poorer and hotter countries. And one more mechanism that can play a role here is related to prices. So during the temperature may induce the changes in prices, and this will of course be also related in the income inequality. Talking briefly about the general setup on income inequality in Russia, The Gini coefficient is quite stable over recent years. It's about 0.3. And if you look into the transition period and the years after, the inequality was initially growing, but in the recent years it is quite stable and even decreasing. However, what is the typical characteristic is that the country is characterized by pro-poor growth. So the inequality is decreasing, but it is happening not because of the increasing incomes in the richer groups, but increasing incomes in the poorer groups. And to some extent, it could be also attributed to changes in returns to employment in different sectors. And if we talk about the extreme poverty and poverty in general, this is relatively low in general in Russia, but still the upward mobility and the possibility to move across the income distributions to a higher group is still quite limited. And there are also quite some number of differentiation between the income distributions between the regions. Talking about the weather, so the coldest temperature is experienced in January. This is on average -25, and the highest and warmest month is July, which is +15. So these are the numbers for sort of average numbers across the full countries. There are of course differences between regions on that, but as you see, it is as compared to maybe some countries that are closer to the equator, this is relatively not hot still, and the climate is mostly continental with hot summers and colder winters. But what is also observed, especially in the recent decade, is that country is warming up quite substantially, and the number of hot days, by hot days I here mean the days above 25 degrees on average, this number is increasing, and the number of hot days actually increasing quite substantially fast, even higher than the global average. Also, this is the picture presenting you the differences between the regions and over time. This is the sort of the highest aggregation, sort of comparable to NUTS1 level of the European classification of regions. In the analysis, we are using the more detailed data about 70 plus regions, but this is here to show you that there are variations between the number of hot days, both over time and also between the regions. So there are some regions that are experiencing the number of hot days constantly and in increasing number. There are some regions that are experiencing this number hot days relatively to lower extent, and this is also changing over time. If you look on average, this is the number of hot days is increasing. Coming to our empirical model, I will explain you what we are doing here. So our dependent variable of interest are different income distribution indicators, and here I mean several indicators related to real GDP per capita, the shares of income earned by different income groups, poverty, Gini, 90 to 10 income percentile ratio. So we are looking into the impacts of extreme temperatures and precipitation on this set of different indicators. The explanatory variables here are related to the different weather indicators, and this is the keyword here is bin. Bin is the number of days in a specific region in a specific year on which the temperature is within the certain limit. So we include the single day bins, which is the number of days below -23 degrees in each region in each year, and also single bins for the above 25 degrees, the number of days with this temperature range that specific region and specific year experience. And we also control for the single days with the precipitation. These are the bins related to the precipitation 10 to 20 millimeters and above 20 millimeters. What we also do, we control for the consecutive bins, which means the number of days of at least 3 consecutive days with such temperature, minus 23 or above 25. So if there is, let's say, a spell of 4 days, this would be the 4 days in this specific consecutive period range. So this would be helping us to control for the sort of higher intensity of the extreme temperature exposure. So if single days may have one impact, and days that are repeated consecutively may have a different impact. All of these would be compared with the days with non-extreme temperatures, with a single day or with non-extreme temperature in the range minus 23, 25. In the robustness checks, we also extended it and looked into different temperature ranges. So looked into these bins, the intermediate bins separately.
So yeah, what's the, on average, what's the temperature above 25 degrees? I'm just thinking if it's 25.2 degrees or 25.5 degrees, it's still kind of within the range of your.
Yeah, about 25 is the 24 hours average. So it will be, of course, cooler in the night and hotter during the day. So the day would be, depending on the region, could be from 27 to 40.
Okay.
And yeah, the nights would be cooler.
Yeah, sure.
So I just have a quick question. When you look at your rain or snow, can they be on the same footing? Because usually, well, you know what I mean? Because when you look at the January, presumably most of the stuff falling is snow rather than rain. So how can they be on the same equal footing? I mean, is there any way to distinguish that?
Well, for us, it is important what is the amount of precipitation here, and basically whether it is snow or the rain, it would be yeah, depending also on the season. And if you look into the colder temperatures, that would be of course related to together with the snow. But I think conceptually it would not be that important for ours.
Well, I don't know, because I live in Vermont, and usually when we get about 15 inches of snow, that's like an average, like about 1 inch of rain. So, I mean, for us to treat on par, you know what I mean? Because most of the stuff we get is from snow rather than from rain. So I was just curious whether there's any way something can be done, because it's not like 1-to-1, right? Because the ratio between 1 millimeter of snow and 1 millimeter of rain is not the same. But anyway, I was just curious.
Yeah, thanks.
Something can be done.
In terms of maybe like how that would affect labor market, as far as I know, for example, there are certain regulations regarding working outside, and that are related specifically always due to temperature. So it is, if it is extremely cold temperature, kids, for example, don't go to school, and also certain outdoor activities are not permitted. If it is extremely hot, it is also related to the certain labor market regulations. But as far as I know, this is not it is directly related to the amount of precipitation and whether it is snow or heavy rain. But yeah, maybe it could be also interesting to talk about this in more detail. Thanks.
Okay, thank you.
Yeah, we also control for the regional fixed effects and the year fixed effects and different regional specific linear trends. In such models, it is not usual to include any kind of economic indicators into the specification. primarily because this would be creating an over-controlling problem, because weather indicators are actually affecting a lot of different economic indicators too. So to measure the total effect of temperatures, we need to look specifically into these weather indicators, controlling for all the possible fixed effects. But including any extra economic controls in such model would create not advisable results and biased results in our case. So those would be the bad controls that would only skew our overall picture. Data that we are using are coming initially from more than 500 meteor stations in Russia for the period 1995 to 2015. The data initially at the meteor station level, and we aggregated using the weighting schemes to the regional level. So for each meteor station, we find nearest settlements within 200 kilometers, and for the Russian setting, 200 kilometers is not a very high distance. So then we also use the population of these settlements as a weights. This allows us to create a temperature experienced by the average person in the region. And there are certain different approaches to this in the literature. For example, there is also approach to do such weighting using not the population but the area. But for us, it is important that what would be the impact felt by the average person, not by the kilometer squared in the data. And then we are using a number of indicators related to income distribution, GDP. Like I mentioned in the previous slide with the methodology, GDP, income groups, Gini indicators, and also for the mechanisms, we are looking then into employment, migration, distribution of wages and employments across the region. The data are then for the 79 regions of Russia. That would be the equivalent to NUTS 2 level of European classification. And as I mentioned, we are also disentangling the regions between the relatively rich and relatively poor, relatively cold and relatively hot. And this is done based on the mean over country. So if as I explained, if the region has mean GDP higher than the mean over country, then it would be considered as a relatively rich region, and if lower, than relatively poor. And for cold hot, this is based on the number of days above 25. So if it is above the average, then it is hot region. If it is below the average, this is the cold region. This is roughly the distribution of our data, which is the graph composed for the whole country over the period of 20 years. We have such data for each region for each year, but this is to show you the overall picture. So what is here in gray are considered for us extremely hot temperatures and extremely cold temperatures. For the extremely hot, we are taking above 25 degrees, so we are combining these two together, but in the robustness checks, we also disentangle this into the two different bins. And this range is the range that is experienced by all the regions of Russia. And this is also important to show these average impacts of such temperature. And for the cold temperatures, this is also the range that is experienced by all the regions of Russia. What is the in between is the number of days in specific temperature ranges, and this would be a default category. So a single day in this range would be our default category. So when we are finding certain impact of above 25, this is as compared to the default category of single day, single non-extreme day. And now coming to the first results, First of all, here in the columns, you see different indicators starting from GDP, then 5 income groups, then poverty rate, Gini index, and the 90:10 ratio. And here, what we see first is that cold temperatures do not have any impacts on these indicators. So, be it consecutive cold days or single cold days, there is no impact on the different indicators. Where the results are coming related to the hot days. And first, we observed that, for example, the single hot day does not affect GDP per capita, but the consecutive days do affect and reduce the GDP per capita. So if hot days come in a row of at least 3 days, this would be reducing GDP per capita. The impact may seem small, but this is the first of all the impact of just 1 day in a consecutive row. And if we think about the overall impacts, that the number of such hot days is increasing over time, this would lead to substantial losses in the GDP over time. The single days have effects on the incomes of the relatively poorer groups, so the lower and lower middle groups, and this is also sort of supporting the pro-poor growth. So if the number of single days is increasing, then 1 single day would increase the share earned by the lowest income group. We also have here some impacts of extreme precipitation on the inequality indicators. And this is, from one side, looks like a good picture in decreasing the inequalities. But we will see when we disentangle it into the poor and rich regions, we see that it is basically happening in relatively richer regions. So this is again, the inequality is decreasing, not because of the sort of smoothing the overall income distribution, but in terms of decreasing the shares and decreasing the incomes earned by the richer regions. So this is again in the sort of supporting this pro-poor growth in the data. When we disentangle it to poor and rich regions, we see that the GDP impact of the impact of consecutive days on GDP is coming primarily from the impact on the poorer regions, and also in terms of the impact on the lower income groups, it's again on the poorer regions. Here there are some effects. Again, for the higher income group, the effect is here marginal, but it is still showing that the share of income earned by the higher income groups is decreasing. And for the Gini indicators, the consecutive days also could slightly decrease the Gini indicators. When we look into the rich regions, the highest impact here would be also related to poverty. So the richer regions, due to the extreme weather conditions, become relatively poorer. And this is also conferred by the indicators here, by the shares of income earned by the lower and middle income groups. So with the extreme weather conditions, the incomes earned by the lower income groups are slightly increased. We will talk in a few slides about the channels, why this is happening, and you will see that this may be related to different economic explanations. Then we also disentangle the results between hot and cold regions, and here in the first column, this is the result for all regions, and when we disentangle them into hot and cold, we see that the impact of consecutive hot days is basically concentrated and more relevant for the relatively hotter regions. So these would be the regions that experience the hot days more frequent than the average region. And this also means that the higher the exposure, the higher would be the impact. And this is actually a bit different from what is typically found, let's say, in the health and epidemiological literature, where if you look into such thing for mortality, for example, there is such thing that is if the temperature is experienced regularly, then the human body adapts and there is no much impact. In terms of the economic structure, this is actually opposite. The higher the exposure, the more likely will the negative effects will occur. Now talking about the channels, we looked into several indicators that would help us to explain why this impact of weather on the inequality and income distribution indicators occur. And this is based on the mechanism that I explained to you based on the literature. So we looked into the changes in the monetary value of fixed consumption basket. This is so there is certain consumption basket, and its value is measured regularly. And in the Russian regional data, is believed to be a much better indicator of capturing the regional inflation, because the regional CPIs, they are computed usually from year to year, and comparing them over a certain period would be quite a difficult task. While here we can make it as a real changes and look also indirectly into the price changes this way. Then we look into the relative wages in different economic sectors. So we are having wages in all the regions in different economic sectors, and we look how the weather would be affecting these relative wages. Then there is a share of employed in different sectors, unemployment, and migration. Based on the literature, this could be related to these mechanisms that I explained to you in the beginning. So what we find here for the prices, changes in the value of fixed basket, yeah, this is one of the channels that may explain changes in the income distribution, since the consecutive days above 25 would increase this value of the fixed basket, meaning that they lead to the changes in prices, increases in prices, and this may be the effect that then translated to income inequality. And this effect is more concentrated in the relatively poorer regions. So this is leads to changes in the temperature would change the prices in relatively poorer regions primarily. And this is also actually related to the extreme precipitation. Here again, there is an increase in the value of fixed basket due to extreme precipitation, and it is again concentrated in relatively poorer regions. Then we look into unemployment, and again, consecutively hot days, they increase unemployment. If you look into all regions, when we disentangle this into poor and rich, hot and cold, the effect is observed in relatively poorer and relatively hotter regions. For the consecutive cold, as in previous table, we don't have any results. So this is not the mechanism that would explain any results related to single days, but consecutive days could be explained by this mechanism. Then we look into the relative wages. Here, these 4 boxes would be showing you the impacts of single hot, single cold, consecutive hot, and consecutive cold day. And these spikes are actually different industries. So the relative wages in different industries, I didn't plot here what exactly is meant by each spike, but actually you could see that this is not the mechanism that explains our results. And vast majority of the effects here is not significant, meaning that the temperatures, be it hot or cold, they do not explain changes in wages. Then we look into the similar picture, but for the employment. And here again, for the single hot days, we basically do not have any impacts. There are some impacts on the here in the consecutive hot days, like here, for example, marginally decreasing the share of employed in manufacturing. This might be related to the specific regulations related to outdoor working, maybe, but the effects here are indeed marginal. For the cold days, we here have some effects, but basically they are not that many. So there is increases in the share of employed in manufacturing and in mining, and this is likely to be related to also certain regulations that would forbid working in the outdoors and working in certain industries during extremely cold days, while still this would be preserving the employment in such sectors. So basically summarizing from the employment and relative wages channels, we could say that changes in wages would not be a channel explaining these mechanisms relating the hot days and the inequality indicators, and employment changes would do so, but on very partial basis only. And finally, we also look into the migration because basically changes in temperature could also induce migrations from regions that are more exposed to regions with lower exposure. And what we find here is that single hot days would increase the migration into rich and colder region, and this actually could be related also to economic structure, because relatively richer and colder regions are related to the oil industries, to industries located in the relatively colder regions. And basically this temperature above 25 is not very frequent there. So basically increasing in the number of days above 25 would actually make these regions quite more comfortable for living. While if we say look into the impact of consecutive days, this is actually induces people leaving from such regions. So if such temperature is not very frequent, then it may serve as a mechanism that is attracting people into such regions. But if it becomes relatively more frequent, then it would be less attractive for living there and also less comfortable.
Olga?
Yep.
I had the impression that at least in the 1990s, there was a move from the Northeast to the Southwest in general, right? From the oil, where the weather wasn't so nice, to where it was better, since the constraints to the extent they were effective were off. So you seem to have it going the other way now. So is there, I don't know, different forces? Yeah.
Actually, this is also quite corresponds to realities, because there are generally there is also a lot of work done in such regions on some not a permanent basis, but you go there for some time, work there, earn money, and then return back. And what is also quite regular there is that people go to such regions for quite some time, earn their retirement benefits there, and then relocate to relatively more comfortable regions only after
Okay.
retirement.
So it's like Alaska or North Dakota in the US.
Yeah, kind of.
Okay.
Olga, could I also ask about your focusing on the plus 25 and minus 23? Like I was just sort of thinking, you know, like I grew up in Canada, and it's also a very cold country for much of the year. But I'm just thinking, you know, if there were sort of areas that received like warmer than usual weather during the winter, that would have a dramatic impact on the local economy. In other words, if the lakes are frozen over, then they drive trucks over the lakes and things like that. But if it's not minus 40 and it's only minus 10, you can't do that. And none of that sort of variation is picked up in sort of what you're focusing on, because it's only sort of extreme hot and extreme cold. But like a major event could be, it should be minus 40, but it's only minus 10. How does that show up in your data?
Partially it is addressed by exactly by dividing the regions into relatively cold and hot. So this also captures how frequently you would face such extreme temperatures, and also meaning that in hotter regions, the hotter temperatures would be more sort of usual, and colder regions, hotter temperatures would be less usual.
Yeah, no, I'm just thinking. I'm just thinking of column 4, where if it were minus 10, that could be a blistering hot day in the middle of winter, and that wouldn't show up anywhere. So that might be interesting, because that might affect the economic activity. In
our robustness checks, we actually looked into the intermediate temperatures between these minus 23, 25 too. And actually in the middle, you don't have any results. Most of the results are coming indeed in the extremely
very
hot
extreme.
Yes.
Okay. All right. Thank you very much. That's useful to know.
So yes, we did a bunch of robustness checks. First, we included the lags of GDP, even though it is not very advisable to include any economic indicators. We just wanted to see whether this would change our results or not. It does not. Then, partly relating also to Ira's question, we also separated the timing and looked into post-transition sample only, because during transition period, sort of pre-2000s, the economic changes could have been different, but it actually does not show up in our results. If we use only post-transition sample, that would still be the same impacts. Then we tried to make hot even hotter and use the 25 and 25, 28 and above 28 as separate beans. Here you would see slightly higher impact of the 28-degree bean, but such results should be used with a caution, because above 28 is not very usual temperature, and it is not experienced by all the regions yet. Then we used also the lags of temperature and precipitation, sort of to capture whether this is the contemporaneous effects or the effects that are inherited from the past. So these lags of temperature and precipitation, they do not change the main picture of contemporaneous effects, and they also do not matter themselves. And yeah, as I mentioned already, we used the specifications with the intermediate temperature beans. So all these in the range between minus 23 to 25 with the 3 degrees step, and all the intermediate beans are not significant. So they are not changing anything in the distribution indicators. So to summarize, what we find is that primarily consecutive extremely hot days, they induce the uneven development of poor and rich regions. And we see that there are more impacts that are falling into the relatively poorer regions, but still these extremely hot days, they do affect both poor and rich regions. Consecutive hot days, they lead to changes in the reduced GDP per capita, and this is more specific to the consecutive hot days, not the whole single hot days. While the shares of income earned by certain population groups are more affected by the single hot days. Cold temperatures, they do not have effect mostly on the income distribution indicators. And this is also an important result because over time, given the global warming, the number of colder temperatures is actually decreasing. The cold spells are still occurring quite frequently, but on the average, the number of cold temperatures over time is decreasing. So in the future, we would have more exposure to hotter temperatures and lower exposure to the colder temperatures. And the channels behind that are primarily related to prices, to certain extent changes in the employment structures, and the transition from employment to unemployment, and also partly to migration. This would be all from my side, and if we still have some questions, I will be happy to discuss them in more detail. Thank you.
Thank you, Olga. Just before the questions, I just want to say, because there have been a few requests from people asking for the paper. So I'm taking this liberty, Olga, I hope you're okay with it, that when the paper is ready, it will be available on GLO as a discussion paper.
Actually, it might not be possible because the paper is just recently been already accepted in review of income and wealth, and it's in the next weeks it should appear online, and I will be happy to send the link to the journal.
Brilliant. So yeah, paper. So if you could, then there are quite a few in the chat who have asked for. I'll note down the email addresses and I'll send you those email addresses.
Yes, so I will be happy to share the link.
Okay, thank you. So now I think it was Pavel and then Almas for the questions.
Yes.
Sorry, should I keep the slides or should I?
Yeah, I think best to keep the slides just in case. Thanks.
Hi, Olga. Thank you very much for the presentation. And my question is, so if I understand correctly, your specification considers the previous year.
In the robustness checks, we included the lags of temperature and precipitation, but basically these are contemporaneous effects in the main specification.
Yes, so I think it's really interesting to see what's happening over long periods of time. And there is, for instance, a paper by Bento et al. Did you mention it? It's an NBR working paper.
Yeah, I think it is in our literature. Yes.
Yes. So basically, they look at shocks, at weather shocks, as you do, but also on the 10-year average or something like that. And then they consider like this also how things change over long periods of time when you have really climate change, not only a shock, which may be just a disaster or, you know, it may cause damage in the short run. But for instance, when it comes to migration, I would assume that people are more reacting to long run changes that may affect their income, for instance, because of global warming, and they really feel that the income decreases if their source of income is agriculture or something like that. So there should be some difference between shocks and long run effects.
Yeah, I absolutely agree. It would be a very interesting thing to study. And there is also some discussion in the literature, basically, what would be the effects of climate change, what would be the effects of weather. Unfortunately, given our data, we are limited from our dependent variable side. We don't have economic indicators to study on the very long run. For the temperature, it may be available for last 50 or 60 years, But for the economic indicators, we on the regional level, we would not have such data. So basically, to put it short, in our specification, we are able to capture the effects of weather, but it would be too short yet to talk about the effects of climate change given our data. But I agree that it would be absolutely interesting to look into that in more details when more data would be available.
Okay, thank you.
Almas?
Thank you for the presentation. I'm sorry I missed the first part of that presentation. Probably you already have mentioned answer to my question. My first question is, did you measure the change in temperature in relation to the region's average temperature over some years or national?
We are basically computing for each region and for each year, for each region in each year, we are computing the number of days with the specific temperature. So this would be the impacts of, so for example, the explanation would be the being above 25 would be showing you the impact of 1 day with the temperature above 25 in the average region.
But within the same region, because the reason I say is because vegetation or say agriculture is adapted to a certain temperature. So you cannot use the same temperature outside the region and those vegetation within the region. So it must be in relation with the same region.
Yeah. This is the final framework fixed effect.
My question was, you talk about inequality and poverty. So this means the source of income is important. And the change in temperature and precipitation, it affects agriculture and rural population, not the urban population. So then it means one should have a share of population that is in rural area in some way in the regression, so that is subject to biggest changes because of these changes in temperature and precipitation. But you don't have any such a share of population.
We do not disentangle results between the rural and urban population. That's true.
I know, but the temperature affects rural, not urban.
I think that is also given from the literature. The impacts would be, maybe to a certain extent the exposures would be more in the relatively rural in the rural regions, but it would be still observed in the urban regions too, because it also affects productivity of different people. People also work outside.
Yes,
in urban
and then
areas.
Inequality and poverty is affected also depending on how big share of the population is suffering from these changes. So that's why I thought having share of the population that is living in rural area, if you add it, it does control for who is subject to these changes and how directly through temperature and precipitation and also indirectly through inequality and poverty. It's just a suggestion if you use again the data.
Yeah, thanks.
Thanks.
Okay, I think this is a good time to stop. Thank you so much, Olga, for a very interesting talk. And thank you everybody else for joining us. And there's a clap going around the world. Thank you everyone for joining and for your questions. Next seminar, first Thursday of next month. Until then, bye.
Thanks a lot for the comments and questions.